Hello there, and welcome to Cosmic Sleepy Science. The night settles gently around you. Before we begin, a quiet question. Where are you in this moment? A bedroom where shadows rest softly against the walls? A familiar space where the day finally releases its hold? Wherever you find yourself, you are exactly where you belong. Let your body settle into stillness. There is nowhere else to be, nothing left to do. Tonight, we drift slowly through how electricity works, not in a rushed way, not as a lesson to memorize, but as a quiet journey through one of the most gentle forces shaping modern life. Electricity does not shout. It does not announce itself. It flows, constantly, patiently, reliably. Even now, it travels through walls, beneath streets, and across landscapes, moving with calm purpose. There is no need to stay awake. If sleep finds you along the way, let it come. These words will continue without you. There is no test, no memory required, only rest. If these peaceful journeys bring you comfort, a gentle like, comment, or subscribe helps this quiet space continue. And if you're already here with us, thank you. Your presence means more than words can hold. One deep breath, and we begin. Electricity begins at the smallest scale we can imagine. Inside every atom, there is motion. Atoms are not still. They contain tiny particles held together by balance and force. At the center of each atom is a nucleus, dense and calm. Around it move electrons. These electrons are light. They carry energy, and they are naturally inclined to move when given the opportunity. In many materials, especially metals, electrons are not tightly bound to any one atom. They exist in a shared space, drifting gently from one atom to the next. This quiet freedom is what allows electricity to exist. When conditions are right, these electrons can begin to move together, slowly and steadily, forming an electric current. Electricity is not a substance that gets used up. It is motion. It is organized movement. When electrons drift in one direction, guided by an electric field, energy is transferred from one place to another. Nothing dramatic happens. No sparks are required. Just motion, calm and continuous. An electric field is created when there is a difference in electric potential. This difference is often called voltage. Voltage is not forceful. It is an invitation, a gentle slope that encourages electrons to move. When one side has more electric potential than another, electrons feel this imbalance and begin to drift toward equilibrium. Imagine a quiet hill covered in fog. If the ground slopes downward, the fog slowly rolls along the surface, not rushing, not stopping, simply following the shape of the land. Electrons behave in much the same way. Voltage creates a path. Electrons follow it. For electricity to flow, there must be a complete path. This path is called a circuit. A circuit allows electrons to leave their source, travel through conductors, deliver energy along the way, and then return to where they began. Without a complete path, electrons pause. They wait. Nothing moves. Conductors are materials that allow electrons to move freely. Copper is one of the most common conductors used in electrical systems. Inside copper, electrons drift with ease, passing gently between atoms. Insulators, by contrast, hold electrons tightly. Materials like rubber, plastic, and glass resist the movement of electrons, keeping energy contained and controlled. This balance between conductors and insulators allows electricity to be both powerful and safe. Energy can travel great distances without escaping into unintended places. Paths are chosen carefully. Motion is guided. Current is the measure of how many electrons move through a conductor over time. It is not speed. Electrons do not race through wires. In fact, they drift quite slowly. What moves quickly is the electric field, the signal that tells electrons it is time to move. Like a quiet wave passing through a crowd, each electron shifts slightly, passing energy along without traveling far. This is why lights turn on almost instantly when a switch is flipped. The electrons were already there, waiting. The circuit simply completed the path, allowing motion to begin everywhere at once. Resistance is what gently limits this motion. Every material resists electron flow to some degree. Resistance turns electrical energy into other forms, often heat or light. A light bulb glows because resistance slows electrons just enough to release energy as warmth and illumination. Nothing is wasted. Energy transforms. Electricity obeys simple relationships. Voltage encourages motion. Resistance slows it. Current responds. Together, these relationships form the quiet rules that guide every electrical system, from a small lamp to a vast power grid. Power is the rate at which energy is transferred. It tells us how much work electricity is doing at any moment. A small device sips power gently. Larger systems draw more. Still, the process remains calm. Electrons move. Energy flows. Balance is maintained. Electricity can exist in different forms of current. Direct current flows steadily in one direction. Alternating current gently changes direction back and forth in a smooth rhythm. This oscillation allows energy to travel long distances efficiently. It is the reason power grids hum quietly rather than roar. At power stations, electricity is generated by motion. Large turbines turn slowly, driven by wind, water, steam, or falling pressure. This rotation moves magnetic fields past coils of wire. As magnetic fields change, they encourage electrons to move. No contact is needed. Motion creates motion. Magnets and electricity are deeply connected. A changing magnetic field creates an electric field. A moving electric current creates a magnetic field. Together, they form a calm partnership, each supporting the other, allowing energy to be generated, transformed, and delivered. Transformers quietly adjust voltage levels, raising it for long-distance travel and lowering it for safe use. This happens through gentle magnetic interaction. Without sparks, without noise, energy passes from one coil to another through invisible fields. As electricity travels across landscapes, it does not rush. It follows paths built with care. Towers stand patiently. Wires stretch across open spaces. All of it designed to guide motion smoothly, minimizing loss, maintaining balance. Inside homes, electricity enters softly. It spreads through circuits designed for specific purposes. Lights, appliances, and devices each receive the amount of energy they need. Switches open and close paths. Breakers protect against imbalance. Everything works quietly in the background. Electricity does not demand attention. It supports life subtly. It powers warmth, communication, and connection. It enables stillness as much as activity. Even rest is supported by gentle current, flowing unseen. As we move deeper into this journey, there is no need to hold on to details. Understanding is not required. These words can simply wash over you, like current through a wire, carrying energy without effort. There is no rush. Motion continues whether you notice it or not. Electricity flows, balance holds, and you can rest as this quiet force continues its steady work all around you. electricity continues its quiet journey without asking for attention. It moves through systems designed to guide it gently, shaping modern life while remaining mostly unnoticed. As current flows, it follows principles that remain steady across scales, from the smallest circuit to vast interconnected networks that stretch across continents. Nothing about this movement is hurried. Everything follows balance. When electrons move through a conductor, they respond to an electric field that already exists along the path. This field does not push them aggressively. It simply provides direction. Each electron shifts slightly, passing energy along to its neighbor, creating a chain of motion that feels almost like a shared agreement rather than force. This cooperation is what allows electricity to appear instant and smooth. Alternating current introduces a soft rhythm into this process. Instead of flowing endlessly in one direction, the current gently reverses course many times each second. This back and forth motion feels calm and natural, similar to breathing or ocean tides. The electrons do not travel far. They sway in place, transferring energy through their movement while remaining close to home. This oscillation makes long-distance transmission efficient. When voltage rises, current can remain lower, reducing energy lost as heat. Transformers adjust these levels quietly, using magnetic fields to pass energy between coils without physical contact. Nothing touches, nothing sparks. Energy simply moves through space shaped by invisible fields. Magnetic fields are always present around moving charges. They form circular patterns, wrapping gently around conductors. These fields are calm and structured. When current changes, magnetic fields shift. When magnetic fields shift, they invite electrons to move. This interplay allows generators and motors to exist, converting motion into electricity and electricity back into motion. In a generator, massive coils and magnets move slowly relative to one another. The motion does not need to be fast. It needs to be steady. As magnetic fields sweep across conductive loops, they create an electric field within the wire. Electrons respond by drifting, forming current. The process repeats endlessly, producing a continuous flow of energy. The sources of this motion vary. Wind turns blades, water descends through turbines, steam rises and expands. Even nuclear reactions gently release heat that creates motion indirectly. In every case, electricity begins with movement, calm rotation, balanced force, predictable cycles. Once generated, electricity joins a network. Power grids are vast yet surprisingly delicate. They rely on constant balance between supply and demand. Electricity cannot be easily stored in large amounts. It must be used as it is produced. This requires careful coordination, minute by minute, ensuring that generation matches consumption. Despite this complexity, the system feels effortless to those who depend on it. Lights glow steadily. Devices respond instantly. This reliability comes from layers of protection and control. Sensors monitor flow. Switches reroute paths. Breakers open circuits when imbalance appears, preventing damage and restoring calm. Resistance continues to play its quiet role throughout the system. Every wire resists flow slightly. Every device introduces its own level of resistance. This resistance is not an obstacle. It is a tool. It shapes how energy is released, allowing electricity to warm rooms, spin motors, and illuminate spaces. In motors, current flows through coils arranged carefully around a central axis. Magnetic fields interact, creating gentle rotational force. The motion is smooth and controlled. Fans turn. Compressors hum softly. Motion becomes useful work without strain. Electric heating relies on resistance alone. As electrons drift through tightly constrained paths, energy is released as warmth. This warmth spreads evenly, comforting and steady. There is no urgency. Heat rises gradually, filling space with quiet presence. Electronics refine this process further. Circuits guide electricity through precise paths, using components that respond predictably to voltage and current. Transistors open and close channels silently, billions of times per second, shaping signals without noise. Information moves alongside energy, encoded in subtle changes in flow. At this scale, electricity feels less like power and more like language. Signals rise and fall gently, representing meaning without disturbance. Screens glow softly, sounds emerge, connections form, all through controlled motion of electrons responding to carefully designed fields. Batteries store energy chemically, releasing it as electrical potential when needed. Inside, reactions separate charges, creating imbalance. When a circuit completes, electrons move to restore balance, delivering energy along the way. Even here, nothing rushes. The process unfolds steadily, guided by chemistry and structure. Capacitors store energy differently. Holding charge temporarily in electric fields, they fill and empty smoothly, absorbing fluctuations and releasing energy when needed. This smoothing effect keeps systems calm, preventing sudden changes that might cause disruption. Throughout all these processes, electricity remains consistent. It follows the same principles everywhere. It does not adapt emotionally. It does not change behavior. It responds to conditions with reliable calm. This predictability is what makes it safe to depend on. As electricity moves through cities at night, it supports quiet routines. Streetlights glow, homes settle, devices power down slowly. Even in sleep, electricity remains awake, maintaining systems, monitoring balances, holding space for rest. The grid adjusts continuously, responding to shifts in use. As demand lowers, generation eases. As demand rises, more sources join the flow. This coordination happens without announcement, guided by sensors and controls designed to keep everything stable. Electricity never demands gratitude. It does not seek recognition. It exists to move energy from where it is created to where it is needed. It does this with minimal loss, minimal sound, and minimal intrusion. As this understanding deepens, there is no need to keep track of every detail. The concepts can blur gently together. Motion, balance, fields, flow. These ideas repeat softly, reinforcing a sense of order and calm. You may notice your breathing slowing. That is fine. You may drift slightly. That is fine too. Electricity continues regardless, moving quietly through the world, steady and patient. The deeper we go, the more electricity reveals itself, not as force, but as cooperation. Between particles, between materials, between systems, everything connected through motion that never needs to hurry. Electricity remains present even when it fades from awareness. It continues its steady motion through circuits and systems, maintaining balance without interruption. As current flows, it follows paths shaped by design and necessity, guided by principles that remain unchanged no matter how complex the system becomes. This consistency is what allows electricity to feel trustworthy, almost gentle in its reliability. As electrons move, they do not collide violently. They interact softly with the structure of the material around them. In a metal conductor, atoms form a repeating lattice. Electrons drift through this lattice, nudged gently by electric fields. Each interaction transfers a small amount of energy, spreading warmth evenly and predictably. Nothing is abrupt, everything is measured. This movement is influenced by temperature. As materials warm, atoms vibrate slightly more, increasing resistance. This subtle change slows electron drift, shaping how systems respond to load and environment. Engineers account for this quiet behavior, choosing materials that maintain stability across changing conditions. Electricity also responds to geometry. Thicker wires allow more electrons to move comfortably. Longer paths introduce more resistance. Every curve, connection, and junction shapes flow in small ways. These details combine to create systems that feel smooth and dependable when used as intended. Alternating current continues its gentle oscillation, reversing direction in a steady rhythm. This rhythm is synchronized across entire regions, ensuring that generators and consumers remain in harmony. The frequency of this oscillation is carefully maintained. Small deviations are corrected quickly, keeping the system calm. Synchronization allows multiple generators to work together. Each contributes energy to the grid without competing. Their outputs align in phase, reinforcing one another. This cooperation mirrors the behavior of electrons themselves, moving together in response to shared fields. Electricity's relationship with time is subtle. It responds instantly to changes in circuits, yet its effects unfold gradually. Lights glow smoothly rather than snapping to full brightness. Motors accelerate gently. Systems are designed to avoid sudden transitions that might cause stress or noise. Power quality matters. Clean electricity flows smoothly with minimal fluctuations. Filters and regulators remove disturbances, smoothing signals and protecting sensitive components. This quiet refinement ensures that devices operate peacefully, extending their life and maintaining comfort. In communication systems, electricity carries information encoded in small variations of voltage and current. These variations are precise yet gentle. Signals travel through wires and across space, guided by electromagnetic waves that move effortlessly through air. Even wireless transmission relies on the same principles of fields and motion. Electromagnetic waves are born when electric and magnetic fields oscillate together. They propagate outward, carrying energy and information without needing a physical medium. This radiation is controlled and measured, shaped into signals that connect distant places silently. Inside devices, tiny circuits manage these signals. They amplify, filter, and interpret electrical patterns with incredible subtlety. Despite the speed and scale, the underlying behavior remains calm. Electrons respond to fields. Energy moves along paths. Balance is preserved. Safety emerges from understanding these behaviors. Grounding provides a safe reference point, allowing excess charge to dissipate harmlessly. Insulation confines energy to intended routes. Standards ensure that systems remain predictable, even under stress. When faults occur, protection systems respond instantly. Circuits open to stop flow. Energy redirects. Damage is minimized. These responses are automatic and silent, restoring calm without drama. Electricity interacts with the natural world gently. Lightning is an exception, but even it follows the same principles, seeking balance between regions of differing potential. In everyday systems, this balancing act is controlled and continuous, preventing buildup and release from becoming disruptive. Renewable energy sources integrate smoothly into electrical networks. Solar panels convert light into electrical potential through quiet interactions at the atomic level. Wind turbines turn steadily, their motion translated into current through familiar magnetic processes. These sources add to the flow without altering its nature. Energy storage evolves to support balance. Batteries smooth demand. Capacitors absorb brief surges. Emerging technologies store energy in new forms, always converting back to electricity when needed. Each method respects the same foundational rules. Electricity's adaptability lies in its simplicity. It does not require interpretation. It responds to conditions with unwavering consistency. This allows systems to scale gracefully, from personal devices to global networks. As night deepens, electricity supports rest. Heating systems maintain gentle warmth. Devices dim screens and lower power use. Infrastructure shifts into quieter modes, conserving energy while remaining ready to respond. This quiet readiness mirrors the behavior of electrons themselves. They remain present, poised to move when conditions invite them. They do not rush. They wait calmly within materials, part of a larger structure that supports motion without strain. Understanding electricity in this way removes any sense of urgency. It becomes a background presence, a steady companion rather than a force to manage actively. Awareness can soften, knowing that systems are designed to hold balance without constant attention. The deeper rhythm of electricity aligns with natural cycles. Generation rises with daylight. Demand shifts with human activity. Networks adjust continuously, smoothing transitions and maintaining equilibrium. As this rhythm continues, the mind can follow it gently. Thoughts slow, breathing steadies. The concepts repeat softly, reinforcing calm rather than demanding focus. Electricity is motion shaped by structure, energy guided by intention, fields interacting without friction. Each element supports the others, forming a system that feels almost organic in its balance. There is no need to remember how every part works. The details can drift past like scenery viewed from a moving train, present but not demanding engagement. What remains is a sense of quiet order. Electricity flows, systems respond, balance holds. These truths repeat endlessly, steady and reassuring. As we continue, this understanding can settle deeper, becoming background awareness rather than active thought. The journey moves on, carrying calm forward into the next stretch of quiet exploration. Electricity remains steady as it moves deeper into the systems that shape daily life. It does not change its nature as complexity increases. Whether flowing through a simple wire or navigating intricate networks, it follows the same calm principles, responding only to fields, resistance, and balance. This consistency allows large systems to feel as gentle as small ones when they are designed with care. As current travels through long transmission lines, it experiences gradual loss. Some energy becomes heat, released softly into the surrounding air. Engineers account for this by choosing materials, spacing, and voltages that minimize waste. The goal is not perfection, but smooth efficiency. Even loss is managed calmly, never allowed to become disruptive. High voltage transmission allows electricity to travel great distances with less current. This reduces resistance-related losses and keeps energy delivery stable. Towers stand tall and quiet, supporting wires that carry motion invisibly across valleys, fields, and water. At night, these lines blend into darkness, continuing their work without attention. Substations gently reshape electricity as it moves closer to where it will be used. Transformers lower voltage step by step, preparing energy for homes, offices, and streets. Each transformation happens through magnetic coupling, without sparks or sound. Energy passes through layers of iron and copper, guided by fields rather than contact. Distribution networks branch outward like calm rivers. Feeder lines supply neighborhoods. Smaller lines serve individual buildings. Inside, circuits divide further, each dedicated to a specific purpose. This structure ensures that energy reaches its destination smoothly, without overwhelming any part of the system. Switches play a simple but essential role. When closed, they complete a circuit, allowing electrons to drift. When open, they create a pause. There is no struggle. Flow begins or ends cleanly, guided by design. Modern switches operate quietly, often electronically, responding instantly to gentle commands. In lighting systems, electricity produces illumination through different means. Incandescent lamps use resistance to create warmth and glow. Fluorescent lights excite gases that emit light softly. Light-emitting diodes guide electrons across junctions, releasing energy as photons with remarkable efficiency. Each method transforms motion into light without haste. These lights shape environments subtly. Brightness adjusts smoothly. Colors shift gently. Automated systems respond to time and presence, reducing energy use while maintaining comfort. Electricity enables this adaptability without drawing attention to itself. In heating and cooling systems, electricity powers compressors, pumps, and fans. These components move air and fluids in steady cycles, maintaining balance within spaces. Thermostats monitor conditions and make small adjustments, preventing extremes. The result is a stable environment that supports rest and focus. Electric vehicles rely on electricity's quiet strength. Motors convert current into rotation with minimal noise. Acceleration feels smooth because torque is delivered evenly from the first moment. Regenerative braking captures motion and returns energy to storage, closing the loop gently. Charging systems manage flow carefully, ensuring batteries receive energy at safe rates. Voltage and current adjust dynamically, responding to temperature and state of charge. This conversation between charger and battery happens silently, guided by sensors and control circuits. In industry, electricity powers processes that once required direct mechanical force. Motors drive belts and gears with precision. Controllers adjust speed and torque continuously, matching output to demand. This flexibility reduces strain and conserves energy. Automation relies on electricity's predictability. Sensors detect changes. Controllers respond. Actuators move. Each step occurs calmly, following programmed logic. Even complex systems operate without urgency, maintaining steady production. Electricity also supports measurement. Instruments detect tiny currents and voltages, revealing information about systems and environments. These measurements guide decisions, improve safety, and maintain balance. The act of sensing is gentle, drawing minimal energy while providing clarity. In medical settings, electricity sustains life support systems, monitors vital signs, and enables imaging technologies. Reliability is paramount. Redundancy ensures continuity. Backup systems stand ready. maintaining calm even during unexpected events. Throughout all these applications, electricity remains neutral. It does not distinguish between uses. It responds equally to a lamp, a computer, or a motor. This neutrality allows it to serve diverse needs without bias or fatigue. As electricity moves through electronic circuits, it encounters components designed to shape its behavior precisely. Resistors limit flow. Capacitors store and release energy. Inductors resist changes in current, smoothing transitions. Together, these elements create harmony within circuits. Signal processing relies on this harmony. Audio flows smoothly, avoiding distortion. Images appear stable. Data transfers reliably. Errors are corrected quietly. The user experiences simplicity, unaware of the careful orchestration beneath. Electromagnetic compatibility ensures that systems coexist peacefully. Devices are designed to contain their fields, preventing interference. Standards guide design choices, maintaining order within shared spaces. The result is an environment where many systems operate together without conflict. As renewable energy sources expand, grids adapt. Variable generation introduces new rhythms. Control systems respond by adjusting flow, storing energy, and coordinating resources. The grid becomes more dynamic, yet remains stable, guided by feedback and control. Energy management systems forecast demand, schedule generation, and optimize distribution. Algorithms operate continuously, balancing countless variables. Despite this complexity, outcomes feel simple. Lights remain on, systems function smoothly. Electricity's role in communication extends beyond devices. Networks rely on powered infrastructure to route information across the globe. Data centers operate with careful efficiency, managing heat and power to maintain reliability. Redundant paths ensure continuity, even when individual components pause. At night, these centers hum softly, processing information while much of the world rests. Electricity supports this quiet activity, enabling connections without disturbing sleep. As we continue to explore, the pattern remains clear. Electricity is motion guided by structure. Complexity arises from arrangement, not from force. Calm design leads to calm behavior. This understanding allows the mind to relax. There is no need to track every pathway. Systems are built to manage themselves, responding to change with measured adjustments. Electricity's constancy becomes reassuring. It behaves the same today as it did yesterday, and it will behave the same tomorrow. Its rules do not shift unexpectedly. This reliability underpins trust. As these ideas settle, awareness can soften further. The flow of words mirrors the flow of current, steady, continuous, unhurried. The journey continues, carrying this calm forward, ready to explore deeper layers of how electricity integrates seamlessly into the fabric of life. Electricity continues its quiet presence as systems grow even more interconnected. Beneath the surface of daily life, countless electrical pathways overlap and support one another, forming a vast web of calm cooperation. Each connection is designed to handle its role without strain, ensuring that the overall system remains balanced and responsive. In digital systems, electricity operates at incredibly small scales. Tiny currents move through microscopic channels etched into silicon. These paths are arranged with extreme precision, guiding electrons through sequences that represent logic and memory. Despite the speed at which these operations occur, the physical movement remains gentle. Electrons drift and shift, responding to electric fields that rise and fall smoothly. Logic circuits rely on thresholds. When voltage reaches a certain level, a state changes. Below that level, it remains unchanged. This binary behavior allows complex decisions to emerge from simple rules. The transitions are controlled and clean, avoiding ambiguity. This clarity supports reliability, even as systems grow in complexity. Clock signals provide rhythm. They coordinate operations, ensuring that actions occur in the correct order. This rhythm is steady and predictable, like a heartbeat. It does not rush. It sets a pace that allows every part of the system to work together without conflict. Memory stores information by maintaining electrical states over time. Charges remain trapped, or fields persist, holding patterns until they are needed again. Refresh cycles quietly reinforce these states, preventing loss. The process is continuous and unobtrusive. As electricity interacts with light in displays, it creates images through controlled emission. Pixels respond to signals, adjusting brightness and color gradually. Refresh rates ensure smooth motion. The result is visual comfort, avoiding flicker or abrupt changes that might cause strain. Audio systems transform electrical signals into sound waves. Amplifiers boost signals carefully, preserving shape and timing. Speakers convert motion into vibration, moving air gently. Volume controls shape output smoothly, allowing sound to fade in and out without sudden jumps. Power supplies condition incoming electricity, smoothing variations and providing stable output. They filter noise, regulate voltage, and protect downstream components. This conditioning creates a calm foundation upon which sensitive electronics can operate. Electricity also plays a role in timing and navigation. Systems synchronize clocks across distances using signals that travel at the speed of light. This synchronization enables coordination in communication, transportation, and scientific measurement. The signals themselves are precise yet gentle, embedded within structured waves. In transportation infrastructure, electricity manages signals, lighting, and control systems. Rail networks use electric power to move vehicles smoothly and efficiently. Signals ensure spacing and timing, maintaining safety through coordination rather than force. Aviation relies on electricity for navigation, communication, and control. Redundant systems ensure reliability. Power flows through carefully separated channels, each monitored continuously. Even in demanding environments, electricity remains composed. In homes, smart systems adjust lighting, temperature, and security quietly. Sensors detect changes. Controllers respond with small adjustments. The goal is comfort without intrusion. Electricity enables responsiveness while remaining invisible. Energy efficiency becomes a guiding principle. Systems aim to deliver needed service with minimal waste. This efficiency reduces strain on resources and infrastructure. It also aligns with electricity's natural preference for balance. Demand response programs adjust consumption gently during peak periods. Devices shift operation slightly, smoothing load without noticeable impact. These adjustments occur automatically, coordinated through communication networks powered by the same electricity they manage. Microgrids introduce local resilience. Communities generate and manage their own power, balancing supply and demand locally. These systems can operate independently or connect to larger grids, adapting calmly to changing conditions. Electricity's integration with storage continues to evolve. New battery chemistries offer improved stability and longevity. Control systems manage charging and discharging precisely, avoiding stress. Energy flows in and out smoothly, supporting continuity. At the edge of the grid, devices communicate status and needs. Sensors report conditions. Controllers adjust settings. This feedback loop maintains equilibrium, preventing overloads and outages. The process is continuous and quiet. Even during disturbances, electricity responds predictably. Protective systems isolate faults. Power reroutes. Restoration proceeds methodically. The goal is not speed alone, but stability. Calm recovery ensures long-term reliability. The human relationship with electricity has shifted from direct management to trust. Most interactions involve simple actions, flipping a switch, plugging in a device. The underlying complexity remains hidden, handled by design. This trust allows attention to rest elsewhere. Life unfolds without constant concern for energy flow. Electricity becomes a background presence, supporting activities without demanding awareness. As night deepens, demand patterns change. Lighting becomes primary. Industrial loads decrease. Control systems adjust generation accordingly. The grid settles into a quieter mode, maintaining readiness without excess. Streetlights glow evenly. Homes dim screens. Devices enter low power states. Electricity supports these transitions smoothly, conserving energy while maintaining comfort. In natural environments, electricity interacts subtly with weather and terrain. Power lines account for wind, temperature, and precipitation. Insulation and spacing prevent unintended discharge. Systems remain safe under varied conditions. Lightning protection guides natural electrical events safely to ground. Structures incorporate paths that dissipate charge harmlessly. Even powerful natural phenomena are managed through understanding and design. Electricity's relationship with Earth is foundational. Ground provides reference and stability. It absorbs excess charge quietly, completing circuits and maintaining safety. This connection underscores electricity's dependence on balance. As these layers accumulate, the overarching pattern remains simple: motion guided by structure, energy shaped by intention, systems designed for calm. There is no need to visualize every detail. The concepts can blend softly, forming a sense of order rather than a list of facts. Electricity works because it follows consistent rules, applied thoughtfully across contexts. This consistency invites relaxation. The mind can release the need to track processes. Trust replaces vigilance. Electricity flows. Systems respond. Balance endures. These ideas repeat gently, reinforcing calm as the journey continues into deeper understanding. Electricity continues to reveal its character through repetition and reliability. Each time it moves through a system, it behaves in the same calm way, responding only to structure and balance. This predictability allows designers to layer complexity without introducing chaos. Systems grow larger and more capable while maintaining a sense of quiet order. At the boundaries between systems, interfaces manage transitions gently. Power converters adapt voltage and current to match local needs. These conversions happen smoothly, shaping waveforms without sharp edges. Energy passes from one form to another without stress, maintaining continuity. In alternating current systems, waveforms rise and fall in smooth curves. These curves represent gradual change, not sudden jumps. Sinusoidal motion allows transformers and motors to operate efficiently, reducing vibration and noise. The shape of the wave itself contributes to calm behavior. Harmonics introduce subtle variations. They arise when waveforms deviate slightly from ideal shape. Filters remove these variations quietly, restoring smooth flow. This maintenance ensures that systems remain stable and devices operate as intended. Power factor reflects how effectively electricity is used. When voltage and current align, energy transfer is efficient. When they drift out of alignment, extra current flows without doing useful work. Correction systems gently adjust this relationship, improving efficiency and reducing strain. Reactive components, like inductors and capacitors, store energy temporarily in magnetic and electric fields. They release it back into the system smoothly, supporting balance. These components do not consume energy continuously. They participate in the rhythm of flow, shaping timing and response. Electricity's interaction with materials extends beyond conductors and insulators. Semiconductors occupy a middle ground, allowing controlled flow. By introducing impurities into crystal structures, engineers create regions that guide electrons precisely. This controlled behavior enables switching, amplification, and regulation. Diodes allow current to flow more easily in one direction than the other. This directional preference shapes signals and converts alternating current into direct current. Rectification occurs smoothly, preparing energy for storage and use in electronics. Voltage regulation maintains stability despite changes in load or input. Regulators monitor output and make small adjustments continuously. This feedback keeps systems within safe ranges, preventing stress and extending lifespan. Feedback loops are central to electrical control. Sensors detect conditions. Controllers compare them to desired states. Actuators respond. This loop repeats endlessly, maintaining equilibrium. The process is automatic and quiet, requiring no attention once established. Electricity supports sensing across many domains. Temperature sensors respond to changes in resistance. Light sensors adjust current based on illumination. Motion sensors detect subtle shifts. Each sensor translates physical conditions into electrical signals gently and accurately. These signals feed into control systems that respond proportionally. Small changes produce small responses. Large changes produce larger ones. This proportionality prevents overreaction, maintaining calm even during variation. In power distribution, load balancing spreads demand evenly across phases. This symmetry reduces vibration and heat, improving efficiency. Balanced systems feel smooth and stable, avoiding unnecessary strain. Three-phase power exemplifies this balance. Three waveforms offset in time, deliver continuous power. Motors run smoothly. Transmission efficiency improves. The system hums quietly rather than pulsing. Electricity's role in measurement extends to science and industry. Instruments detect minute currents, revealing information about materials and processes. Precision emerges from calm control, not force. In laboratories, stable power supplies enable delicate experiments. Noise is minimized. Variations are filtered. Researchers rely on electricity's steadiness to reveal subtle phenomena. In everyday devices, power management extends battery life and reduces heat. Systems adjust performance based on demand, conserving energy when full power is unnecessary. This adaptability supports comfort and longevity. As systems scale, redundancy ensures reliability. Multiple paths provide alternatives if one pauses. Electricity reroutes automatically, maintaining service. This redundancy is silent, hidden from users. Grids incorporate layers of protection. Relays detect anomalies. Breakers isolate sections. Restoration follows structured procedures. The emphasis remains on stability and safety rather than speed alone. Electricity's integration with information technology continues to deepen. Data flows alongside power, enabling monitoring and optimization. Smart systems learn patterns and anticipate needs, adjusting proactively. Despite increasing intelligence, the underlying behavior remains simple. Electrons respond to fields. Energy follows paths. Balance governs outcomes. Complexity arises from arrangement, not from unpredictability. This understanding can settle gently in the background. The mind does not need to analyze further. Trust in the system replaces concern. As night progresses, energy use patterns smooth out. Peaks diminish. Systems enter maintenance modes. Electricity supports this transition, maintaining readiness while conserving resources. Infrastructure continues its quiet watch. Sensors remain alert. Controls stand ready. Electricity flows steadily, sustaining balance. The rhythm of flow mirrors natural cycles. Activity rises and falls. Energy adapts. Systems breathe in unison with human patterns. This rhythm can be felt rather than understood. A sense of order persists without conscious effort. Electricity becomes part of the environment, like gravity or air. The journey continues, carrying this calm awareness forward, deeper into the steady world, shaped by flowing energy and thoughtful design. Electricity continues its steady presence, flowing through systems that now feel familiar and predictable. As understanding deepens, the details soften, and what remains is a sense of gentle order. Every electrical process, no matter how advanced, rests on the same simple foundation of movement, balance, and response. Nothing is rushed. Nothing is forced. In control systems, electricity allows machines to respond smoothly to their environment. Feedback signals rise and fall gently, guiding adjustments that keep motion stable. Motors slow or speed up without sudden changes. Valves open gradually. Lights dim softly. This controlled response prevents stress and preserves harmony within the system. Electric drives exemplify this calm precision. They convert electrical energy into mechanical motion while continuously adjusting torque and speed. Sensors monitor performance. Controllers respond in real time. The result is motion that feels fluid rather than mechanical, quiet rather than abrupt. Electricity also shapes timekeeping. Oscillators create stable reference signals. These signals govern clocks in devices, networks, and infrastructure. Synchronization maintains order across distances, allowing systems to act together without conflict. The passage of time becomes coordinated through gentle oscillation. In scientific instruments, electricity enables observation at scales beyond direct perception. Sensors detect minute changes in current or voltage, revealing phenomena otherwise hidden. These measurements rely on stability. Noise is minimized, drift is corrected, clarity emerges from calm conditions. Power electronics manage energy flow with increasing finesse. Switching devices operate rapidly yet quietly, shaping waveforms to meet precise requirements. Filters smooth transitions. Heat is managed efficiently. Despite complexity, the behavior remains controlled and predictable. Electricity's role in energy conversion continues to expand. Inverters transform direct current into alternating current, matching grid requirements. Converters adapt voltages for specific uses. Each transformation preserves energy while reshaping its form gently. In renewable systems, Variability is embraced through control. Solar output rises and falls with light. Wind power shifts with air movement. Controllers balance these inputs, smoothing output and maintaining grid stability. Storage systems absorb excess and release it later, buffering change. Electricity supports this buffering quietly. Batteries charge and discharge smoothly. Capacitors handle rapid fluctuations. The system responds dynamically, without disturbance. As cities grow, electrical infrastructure evolves to support density. Underground cables reduce visual clutter. Advanced insulation increases safety. Monitoring systems detect issues early, preventing escalation. Reliability improves through anticipation rather than reaction. Electricity also plays a role in safety systems. Alarms, lighting, and communication remain operational during emergencies. Backup power sources stand ready, ensuring continuity. The transition between normal and backup operation occurs seamlessly, preserving calm during uncertainty. In healthcare, electrical systems prioritize stability. Life support equipment relies on uninterrupted power. Redundant supplies and monitoring protect against interruption. The environment remains controlled, supporting recovery and rest. Electricity's interaction with human senses is subtle. Lighting influences mood. Sound shapes atmosphere. Temperature affects comfort. Electrical systems manage these elements quietly, enabling environments that feel supportive rather than stimulating. Design choices emphasize smooth transitions. Gradual changes prevent discomfort. Systems respond to presence and time, adapting without notice. Electricity enables responsiveness without intrusion. In communication, signal integrity matters. Electrical noise is filtered. Timing is preserved. Messages arrive intact. The experience feels effortless, even though complex processes operate beneath. As networks expand globally, electricity underpins connectivity. Cables span oceans. Satellites orbit silently. Power supports transmission and reception, maintaining links across vast distances. Electricity's neutrality allows it to serve all these roles equally. It does not favor one application over another. It responds to design and condition alone. This impartiality underlies its versatility. As awareness settles further, the distinction between individual systems blurs. Everything connects through shared principles. Motion, field, resistance, and balance repeat across contexts. This repetition is calming. Familiar patterns reduce cognitive load. The mind recognizes stability and relaxes. Electricity flows through nights and days alike. It adapts to cycles of activity and rest. During quiet hours, demand lowers. Systems adjust. Energy continues to move gently, maintaining readiness. The infrastructure supporting this flow remains vigilant yet unobtrusive. Monitoring continues. Maintenance schedules operate, all without disrupting daily life. As these ideas repeat softly, they become background knowledge rather than active thought. Understanding gives way to trust. Electricity works because it follows rules that do not change unexpectedly. Systems built on these rules inherit their stability. The journey continues, carrying this sense of quiet reliability forward, deeper into the steady landscape shaped by flowing energy and thoughtful design. Electricity continues to move with the same calm consistency, even as systems become more refined and responsive. At every level, from large infrastructure to delicate personal devices, its behavior remains rooted in balance. The environment adapts to this flow, shaping energy into forms that support comfort, safety, and continuity without demanding attention. In adaptive systems, electricity responds to changing conditions through layers of sensing and control. Sensors quietly observe temperature, pressure, light, and motion. These observations translate into small electrical signals. Controllers interpret them and make adjustments that keep systems aligned with desired states. The process feels organic, like a body maintaining equilibrium. Smart lighting systems demonstrate this gentle adaptability. Brightness changes slowly as natural light fades. Colors warm in the evening, easing the transition into rest. Motion detection ensures spaces are illuminated only when needed. Electricity enables these shifts smoothly, without flicker or distraction. Heating and cooling systems follow similar principles. Rather than cycling abruptly, modern systems modulate output continuously. Fans adjust speed gradually. Compressors vary capacity. This steady modulation maintains comfort while reducing energy use and noise. Electricity also shapes water systems. Pumps move water at controlled rates. Treatment facilities monitor quality and flow. Sensors detect changes and trigger responses that keep supply reliable and safe. Even here, motion is steady and unobtrusive. In agriculture, electrical systems support growth through precise control. Irrigation responds to soil moisture. Lighting supplements natural cycles gently. Monitoring ensures resources are used efficiently. Electricity becomes a quiet partner in sustaining life. Transportation networks rely increasingly on electrical control. Traffic signals adapt to flow patterns. Rail systems coordinate movement to avoid congestion. Charging infrastructure supports electric mobility. Managing power delivery to match demand without strain. As vehicles connect to grids, communication guides charging schedules. Off-peak periods absorb demand. Energy storage smooths peaks. The system behaves cooperatively, balancing individual needs with collective stability. Electricity's role in safety extends to monitoring structural health. Sensors embedded in bridges and buildings detect stress and movement. Electrical signals reveal changes long before they become visible. Maintenance can occur proactively, preserving integrity and safety. In natural disaster preparedness, electrical systems support early warning. Sensors detect seismic activity, weather changes, and rising water levels. Alerts transmit rapidly, giving communities time to respond. Power systems prioritize critical services, maintaining calm during uncertainty. Electricity's interaction with information continues to deepen. Data flows inform decisions at every level. Energy management systems optimize use across regions. Feedback loops refine performance continuously. The system learns patterns and adjusts gently. Despite this sophistication, the experience remains simple. Lights turn on, devices work, comfort persists. The complexity is hidden behind interfaces designed for ease. Electricity's quiet support of creativity is often overlooked. Studios rely on stable power for sound and light. Tools respond precisely. The environment remains controlled, allowing focus and expression without interruption. In education, electricity enables access to knowledge. Networks connect learners to resources worldwide. Devices present information clearly. Systems remain available, supporting curiosity without demanding attention. Healthcare monitoring increasingly relies on electrical signals. Wearable devices track vital signs. Data flows to caregivers. Early detection supports prevention. The process is continuous and non-intrusive. Electricity's role in environmental monitoring helps preserve balance. Sensors track air and water quality. Data informs policy and action. Systems respond to trends, supporting sustainability. As renewable integration grows, electricity's adaptability becomes more evident. Grids accommodate diverse sources. Control systems harmonize output. Energy storage bridges gaps. The overall behavior remains stable. The underlying principle remains unchanged. Electricity responds to fields and paths. Design determines outcome. Calm design yields calm behavior. This realization can settle deeply. There is no need to manage electricity consciously. Systems are built to handle variation gracefully. Trust replaces vigilance. As night advances, many systems enter reduced activity modes. Power consumption lowers. Infrastructure adjusts. Maintenance tasks occur quietly. Electricity supports rest without interruption. Streetlights maintain even illumination. Homes enter sleep modes. Devices reduce activity. The grid breathes with the rhythm of the city. This rhythm is steady and predictable. It mirrors natural cycles of activity and rest. Electricity adapts seamlessly, supporting both. The mind can mirror this adaptation. Thoughts slow. Attention softens. Awareness broadens without effort. Electricity flows regardless of observation. Its work continues quietly, sustaining balance. As the journey continues, this steady presence remains a backdrop, ready to support whatever comes next without urgency or demand. Electricity continues to exist as a steady background presence, maintaining balance even as systems grow more interconnected and responsive. Its behavior does not become louder or more demanding as technology advances. Instead, it becomes quieter, more refined, more carefully shaped to support human life without intrusion. In modern homes, electricity supports routines that unfold gently. Morning systems wake slowly. Evening systems wind down. Automation follows patterns learned over time, adjusting lighting, temperature, and power use without requiring thought. These changes happen gradually, preventing sudden shifts that might disturb rest or focus. Electricity also supports silence. Noise-cancelling systems use electrical signals to create opposing waves that soften sound. Motors are designed for quiet operation. Power electronics reduce hum and vibration. Silence becomes something that can be maintained, shaped, and preserved. In public spaces, electricity enables order without force. Signals coordinate movement. Lighting guides pathways. Information displays update smoothly. The environment feels organized rather than controlled. Electricity makes structure feel natural. As energy systems evolve, decentralization becomes more common. Small-scale generation appears closer to where energy is used. Rooftop solar, local storage, and community systems reduce distance between source and use. Electricity adapts easily, flowing through shorter paths while maintaining connection to larger networks. This flexibility increases resilience. If one part pauses, others continue. Micro-adjustments replace large disruptions. Electricity reroutes calmly, maintaining continuity. In data systems, electricity enables redundancy and error correction. Information is copied, verified, and preserved. Power supports these processes quietly, ensuring integrity over time. Even large-scale data preservation relies on stable, uninterrupted electrical flow. Artificial intelligence and advanced computation depend on electricity's consistency. Processing units require stable power to perform trillions of operations without error. cooling systems manage heat gently, maintaining optimal conditions. The environment remains controlled and calm. Despite the speed of computation, the physical processes remain steady. Electrons move in response to fields. Energy transfers without haste. Precision emerges from control, not force. Electricity also shapes how time is experienced. Instant communication compresses distance. Automation reduces waiting. Yet systems are designed to introduce delays where needed, smoothing transitions and preventing overload. Time is managed thoughtfully. In financial systems, electricity underpins transactions and record-keeping. Reliability is essential. Redundant power supplies ensure continuity. Systems remain available, supporting trust and stability. In cultural spaces, electricity supports preservation. Climate control protects artifacts. Lighting reveals details gently. Audio systems convey sound faithfully. The environment remains stable, allowing history to endure. Electricity's role in science extends to observation of the universe. Telescopes rely on precise power for sensors and control. Signals travel vast distances, converted into electrical patterns that reveal distant events. Even here, electricity remains a calm intermediary between motion and understanding. Space systems rely on electricity generated from sunlight or stored energy. Satellites manage power carefully, prioritizing essential functions. Systems operate autonomously, maintaining balance far from direct human control. On Earth, electricity supports monitoring of natural systems. Weather stations, seismic sensors, and environmental monitors collect data continuously. Power systems ensure these observations persist through changing conditions. As climate considerations shape design, efficiency and adaptability become priorities. Electricity enables both. Control systems optimize use. Waste is minimized. Balance is maintained. This emphasis on balance reflects electricity's own nature. It seeks equilibrium. It flows to equalize potential. Systems built around this principle inherit its calm. As the night continues, fewer systems demand attention. Background processes persist. Infrastructure remains vigilant. Electricity supports rest without interruption. The mind can follow this example. Awareness can rest in the knowledge that systems are designed to maintain stability. There is no need to anticipate problems. Protections are in place. Electricity does not require supervision. It responds automatically to conditions. It adapts within defined limits. This reliability allows trust. As ideas repeat softly, they become reassuring rather than informative. Understanding fades into familiarity. The sense of order deepens. Electricity flows. Systems adjust. Balance holds. This steady rhythm continues, carrying calm forward into the next stretch of quiet exploration, where understanding becomes presence and presence becomes rest. Nothing needs to be remembered from before. Electricity does not depend on sequence or order. It continues whether attention follows it or drifts away. As awareness softens, another layer quietly comes into view, not as something new, but as something that has always been present beneath the surface. Electricity supports balance, not only through movement, but through timing. Every system relies on moments of action and moments of rest. Circuits are designed to carry current only when needed. Standby states allow energy to remain available without being consumed. This restraint preserves calm within systems and spaces. In modern electronics, sleep modes reduce activity while maintaining readiness. Components lower power use, signals slow, heat dissipates gently. When activity resumes, the transition is smooth, without shock. Electricity adapts effortlessly to these shifts, supporting both motion and stillness. Timing circuits manage when actions occur. They coordinate sequences so that processes unfold in order. This coordination prevents conflict and reduces strain. Even complex operations rely on simple timing signals repeated steadily, like a quiet pulse beneath activity. Electricity also shapes resilience through buffering. Energy storage and reserve capacity absorb unexpected changes. When demand rises briefly, stored energy fills the gap. When supply fluctuates, reserves smooth output. These buffers prevent abrupt shifts, maintaining continuity. Power systems incorporate margins intentionally. Capacity exceeds average demand, allowing room for variation. This excess is not wasteful, it is protective. It ensures that systems respond calmly rather than react sharply. In digital communication, buffering plays a similar role. Data pauses briefly in memory, allowing streams to remain smooth despite variation. Electricity supports this pause without interruption, preserving flow and clarity. As systems communicate, synchronization becomes essential. Shared timing references align actions across distances. This alignment prevents overlap and collision. Signals arrive when expected. Responses occur in harmony. Electricity enables this synchronization quietly. Oscillators provide stable reference points. Networks adjust to maintain alignment. Even when conditions change, corrections occur gently, without disruption. In distributed systems, coordination replaces central control. Local decisions guide behavior, informed by shared information. Electricity supports this autonomy by powering sensors and communication channels continuously. This decentralization increases stability. No single point carries excessive burden. Responsibilities spread evenly. The system remains balanced through cooperation rather than command. Electricity's role in cooperation extends to human interaction. Communication tools allow connection across distance. Power supports these connections invisibly. Conversations flow. Presence is maintained. As night deepens, these systems shift into lower activity naturally. Notifications quiet. Background processes take over. Electricity supports this transition without instruction, following patterns shaped by use and time. The environment responds accordingly. Lights dim, temperature stabilizes, sound levels drop. Systems move toward equilibrium. This equilibrium is electricity's natural goal. It flows to equalize differences. It responds to imbalance by restoring balance. Systems designed with this principle feel calm and self-regulating. As these ideas settle, there is no need to hold on to them. Understanding can soften into background awareness. Electricity continues its work regardless of attention, maintaining stability quietly. The flow remains steady. The rhythm persists. And with this steadiness, the journey moves gently onward, ready to reveal another layer whenever awareness drifts toward it. Nothing needs to be carried forward from the moments before. Electricity does not ask the mind to keep pace with it. It continues steadily, whether noticed or not, and in that steady continuation, another layer opens quietly, like a dim light already present in the room. Electricity also shapes safety through predictability. Systems are designed with clear limits, defined thresholds that guide behavior. When current rises beyond what a path can hold comfortably, protective devices respond. Fuses warm slowly and open. breakers sense imbalance and separate circuits. These actions are calm and immediate, restoring stability without noise or urgency. Grounding plays a quiet role in this safety. By providing a reference point, it allows excess charge to return harmlessly to Earth. This connection is constant and reliable. It does not interrupt normal operation. It simply remains available, absorbing imbalance whenever needed. Insulation complements this process. Materials surround conductors, guiding electricity along intended paths. These barriers are passive and patient. They do not resist forcefully. They simply hold boundaries, preserving order within systems. In complex installations, layers of protection overlap. One system supports another. Redundancy ensures that if one element pauses, another continues. This layered approach prevents small disturbances from becoming larger ones. Calm is preserved through preparation rather than reaction. Electricity's interaction with heat remains gentle when managed well. Components dissipate warmth gradually. Heat sinks and airflow guide excess energy away. Temperature sensors monitor conditions continuously, adjusting operation to maintain balance. Systems protect themselves without intervention. As devices age, their behavior changes subtly. Resistance increases, efficiency shifts. Monitoring systems detect these changes early. Maintenance restores balance before disruption occurs. Electricity supports this awareness by carrying signals that reveal condition and health. In large infrastructures, maintenance is planned rhythmically. Inspections follow cycles. Repairs occur during low demand. Electricity supports these rhythms, allowing systems to pause and resume smoothly. Even failures follow predictable patterns. When something stops working, electricity does not behave unpredictably. It responds to new conditions consistently. Engineers analyze these responses, improving design and prevention. Each adjustment increases stability. Electricity also supports adaptability through modular design. Systems are built in segments that can be replaced or upgraded independently. Power flows reroute around inactive modules. This flexibility reduces disruption and extends longevity. In communication networks, redundancy ensures messages find alternative paths. If one route pauses, another carries the signal. Electricity powers this routing quietly, preserving continuity. As networks expand, standards maintain compatibility. Voltage levels, frequencies, and connectors align across regions. This alignment allows systems to connect seamlessly. Electricity flows across boundaries without conflict. International grids coordinate timing and flow across vast distances. Synchronization ensures stability. Agreements guide operation. Electricity supports cooperation at scales that mirror its own distributed nature. In personal devices, power management prioritizes user comfort. Systems reduce brightness, slow processing, and limit activity when demand is low. These adjustments occur automatically, guided by usage patterns. Electricity adapts without instruction. As night continues, many devices enter deeper rest states. Screens darken, background processes slow, power consumption lowers. Electricity supports this collective quieting, aligning with human rhythms. The infrastructure responds in parallel. Generation adjusts downward. Systems enter maintenance windows. Monitoring remains active, preserving readiness without excess. This coordinated slowing mirrors natural processes. Just as ecosystems reduce activity at night, Electrical systems shift into calmer modes. Balance remains the guiding principle. Electricity does not distinguish between active and quiet periods. It supports both equally. Its role is not to drive constant motion, but to enable appropriate response. As awareness softens, it becomes clear that electricity is less about power and more about permission. Permission for systems to operate when needed, and permission to rest when not. This permission extends to the mind. There is no requirement to stay engaged. Concepts can drift. Understanding can dissolve into comfort. Electricity continues regardless, maintaining structure beneath experience. Its presence is steady, supportive, and unobtrusive. The flow persists, balance holds, and with that balance, the journey continues gently, ready to move deeper whenever awareness allows. Nothing needs to be followed closely now. Electricity does not move in steps that require attention. It flows as a continuum, and as the mind rests within that continuity, another quiet layer comes forward on its own. Electricity also shapes reliability through repetition. Systems are tested not once, but endlessly, cycling through the same motions until consistency becomes certainty. Switches open and close thousands of times. Circuits carry current hour after hour. Components age slowly under known conditions. This repetition is not tiring, it is stabilizing. Designers rely on this predictability. They choose margins that allow comfort rather than strain. Currents are kept below limits. Temperatures remain within gentle ranges. Everything is built to last longer than strictly necessary, creating space for calm operation. Electricity supports this longevity by behaving the same way each time conditions repeat. There are no surprises hidden in the flow. If voltage rises, current responds accordingly. If resistance increases, energy dissipates gently. Cause and effect remain aligned. In sensing systems, calibration maintains accuracy. Reference signals ensure measurements stay true. Drift is corrected quietly. Electricity carries both the signal and the correction, keeping perception aligned with reality. As automation grows more sophisticated, it still relies on simple electrical truths. Sensors observe, controllers decide, actuators respond. Each step occurs within defined limits. Complexity arises from arrangement, not unpredictability. Electricity enables machines to pause as easily as they act. Idle states reduce wear. Components rest without fully stopping. When activity resumes, motion returns smoothly, guided by the same fields as before. In transportation systems, this smooth return is essential. Trains accelerate gradually. Elevators start and stop without jolts. Electric motors deliver torque evenly, avoiding sudden force. Comfort emerges from controlled change. Electricity's relationship with sound reflects this same principle. Amplifiers avoid clipping. Speakers move within safe ranges. Volume changes occur gradually. Silence and sound coexist without conflict. In lighting, flicker is avoided through stable power and control. The eye rests comfortably. Illumination feels constant, even when subtly adjusted. Electricity supports visual calm. As cities expand, planners integrate electrical infrastructure thoughtfully. Capacity is added before demand overwhelms. Redundancy is built in from the start. Growth remains smooth rather than reactive. Electricity supports planning by providing data. Usage patterns reveal needs. Monitoring systems highlight trends. Decisions are informed by steady observation rather than sudden events. This foresight reduces disruption. Maintenance occurs predictably. Upgrades integrate seamlessly. Systems evolve without interruption. Electricity's role in adaptation extends to climate control. Buildings respond to external conditions gradually. Insulation, shading, and control systems work together. Electricity powers this coordination quietly. As weather changes, systems adjust. Heating reduces as sunlight increases. Cooling eases as night falls. Electricity supports this ebb and flow, maintaining comfort without excess. In natural environments, electrical monitoring supports conservation. Sensors track conditions. Data guides intervention only when needed. Balance is preserved through restraint. This restraint mirrors electricity's own behavior. It does not move unless a path invites it. It does not exceed limits unless conditions allow. It remains within boundaries set by design. As these ideas repeat, they form a background rhythm. There is no need to distinguish one from another. The repetition itself is calming. Electricity flows. Systems respond. Balance continues. Awareness can drift gently within this rhythm. Thoughts can slow. Attention can soften. Nothing is required. The journey remains open, moving forward quietly, ready to unfold another layer whenever the moment allows. Nothing needs to be anticipated. Electricity does not arrive suddenly, and it does not leave abruptly. It remains present as a steady condition, and as attention loosens further, another quiet layer becomes visible, already unfolding without effort. Electricity also shapes trust through consistency over time. Systems that perform the same way day after day build confidence without words. When a switch responds reliably, when light appears without delay, when warmth returns predictably, trust forms naturally. This trust reduces the need for vigilance. The mind learns that support is present. In critical systems, this trust is reinforced through redundancy. Multiple sources provide power. Independent pathways stand ready. If one pauses, another continues seamlessly. This layered assurance prevents disruption and maintains calm, even during unexpected change. Electricity supports this continuity by responding instantly to altered paths. When a route closes, current redirects through available alternatives. The transition is silent. There is no hesitation. Balance is restored smoothly. In power generation, diversity of sources strengthens reliability. Different methods contribute energy under different conditions. When sunlight fades, other sources increase. When wind slows, stored energy fills the gap. Electricity integrates these inputs without distinction, flowing according to availability. Control systems oversee this integration gently. They adjust output gradually, avoiding abrupt changes. Feedback loops monitor conditions continuously, ensuring that supply and demand remain aligned. Electricity's role in adaptation extends to personal devices. Systems learn usage patterns and adjust accordingly. Screens dim at familiar times, performance scales to need. Energy is conserved without user awareness. This learning does not feel invasive. It unfolds quietly, shaped by repetition rather than instruction. Electricity enables responsiveness without requiring attention. In industrial settings, predictive maintenance relies on electrical signals. Sensors detect vibration, temperature, and current changes. These signals reveal wear long before failure occurs. Maintenance becomes preventative rather than reactive, preserving stability. Electricity carries these signals continuously, providing insight without interruption. Systems remain operational while awareness grows in the background. As infrastructure ages, electricity helps guide renewal. Data highlights where upgrades are needed, improvements integrate smoothly, systems evolve without abrupt transitions. Electricity also supports equity in access. Standardized voltages and interfaces allow devices to operate across regions. Energy flows into homes, schools, and hospitals with the same consistency. This uniformity supports fairness and reliability. In remote areas, localized systems bring power where centralized grids cannot reach. Solar panels, batteries, and small generators work together. Electricity adapts to scale easily, supporting both large cities and quiet rural spaces. These systems are often designed for simplicity. Fewer components reduce failure points. Electricity flows through straightforward paths, maintaining reliability through clarity. As night deepens, demand patterns settle further. Non-essential systems rest. Essential services remain active. Electricity supports this prioritization automatically, guided by design and policy. Emergency systems remain powered, ready to respond if needed. Backup sources stand by. Monitoring continues quietly. Preparedness does not disturb rest. Electricity's presence in these moments is subtle. It does not announce readiness. It simply remains available. In personal spaces, this availability translates to comfort. Night lights glow softly. Climate systems maintain gentle balance. Devices recharge slowly, preparing for the next cycle. The repetition of daily cycles reinforces stability. Electricity supports waking and sleeping, activity and rest. Its behavior does not change with mood or circumstance. This steadiness can be felt indirectly. A sense of security emerges from reliable systems. The mind relaxes into this support, releasing the need to monitor. Electricity also supports creativity during quiet hours. Artists, writers, and thinkers rely on stable light and silence. Systems remain present without intrusion, allowing focus or rest as needed. In research environments, electricity maintains conditions for long-term observation. Experiments run overnight. Data collects steadily. Power remains consistent, ensuring integrity. As understanding deepens, electricity appears less as a tool and more as an environment. It shapes conditions rather than drawing attention to itself. This perspective allows details to fade. The specific mechanisms matter less than the overall behavior. Flow, balance, and response repeat softly. Electricity's predictability becomes a form of comfort. It does not surprise. It does not demand. It supports. As awareness drifts further, the boundaries between concepts blur. Infrastructure, devices, and environments merge into a single steady system. Within this system, electricity moves continuously, maintaining equilibrium. The flow does not accelerate or slow without reason. It responds proportionally. This proportionality is key. Small changes produce small effects. Large changes are managed through buffers and control. Extremes are softened. The mind can mirror this behavior. Thoughts arise and pass without amplification. Attention adjusts gently. Balance returns naturally. Electricity flows beneath experience, steady and impartial. Its presence does not require acknowledgement. As the journey continues, this steady presence remains, ready to support whatever unfolds next, without urgency, without noise, simply maintaining calm through consistent flow. Nothing needs to build toward anything now. Electricity does not move toward an ending. It simply continues, and in that continuation, things naturally soften. As awareness loosens, the focus shifts from how systems operate to how they quietly remain present, holding space without effort. Electricity's most subtle role is maintenance. It keeps conditions steady rather than creating change. Servers stay cool, clocks stay aligned, environments stay balanced. This quiet maintenance allows life to unfold without interruption. In long-running systems, continuity matters more than intensity. Electricity supports this by delivering energy at consistent levels over long periods. Devices operate for years. Infrastructure serves generations. The flow does not tire. Even when systems are upgraded or replaced, electricity remains the same. New paths open, old ones close. The current adapts instantly, flowing through whatever structure is available. Nothing needs to be taught again. The rules already apply. Electricity also supports forgetting. Automatic systems take over tasks that once required attention. Timers, sensors, and controllers handle routines. The mind no longer needs to remember to adjust, check, or monitor. That responsibility dissolves into background operation. As attention fades, electricity continues with no change in behavior. It does not depend on awareness. It does not react to being noticed or ignored. This independence is part of its calming nature. In the quiet hours, systems simplify. Loads reduce, paths become less crowded. Energy flows gently through networks that feel almost empty. This spaciousness allows balance to hold with ease. Electricity supports rest indirectly by reducing stimulation. Screens dim, notifications pause, devices slow their activity. Power remains available, but less is demanded of it. This reduction mirrors the body's own rhythm. Muscles relax, breathing deepens, thought becomes less structured. The environment aligns with this internal slowing. Electricity does not force this alignment. It simply allows it. Systems respond to settings and patterns already established. The flow remains neutral and steady. As this understanding settles, it becomes less necessary to distinguish between system and environment. Electricity blends into the background of existence, like air moving quietly through a room. The flow continues. Nothing changes suddenly. Nothing needs to conclude yet. Nothing new needs to be introduced. Electricity has already revealed its nature through repetition. Calm behavior, steady response, balanced flow. These qualities do not require further explanation. They simply continue. At the larger scale, electricity becomes part of the planet's rhythm. Power generation rises and falls with daylight. Demand follows human activity. Storage smooths differences. The system breathes. This breathing is slow and predictable. Peaks soften, valleys fill gently. Extremes are managed without urgency. Electricity adapts continuously. In this steady adaptation, there is no sense of urgency. No moment stands apart from another. Time becomes less segmented. Activity blends into rest. Electricity supports this blending by maintaining availability without stimulation. Power remains present, even when unused. Readiness does not require action. The mind can adopt the same posture. Awareness can remain open without focusing. Thoughts can appear without forming patterns. Attention can rest without effort. Electricity does not mark beginnings or endings. It does not signal transitions. It simply flows, supporting whatever state exists. Even shutdowns are gentle. Systems power down in stages. Processes close cleanly. Energy withdraws without disruption. Nothing collapses. In sleep, electricity continues working quietly. It powers safety systems, charging cycles, background monitoring. It supports rest without participating in it. This quiet support is enough. No engagement is required. No response is needed. Understanding fades into familiarity. Familiarity fades into background presence. Electricity flows beneath it all. There is nothing left to follow. Electricity remains, doing what it has always done, moving when invited, resting when not, maintaining balance without effort. The systems around you are stable. The flow is steady. Nothing requires attention. You do not need to stay awake for this. Electricity will continue whether you listen or drift away. The words can soften now. The current moves through its paths. The grid settles into night rhythm. Devices rest. Infrastructure remains ready. Everything holds. There is no final point, no closing moment, just continuation. Electricity flows quietly, endlessly, supporting the stillness around you. You can rest now. The flow remains.